Hello, fourth period. Happy Monday. I hope you guys had a really nice weekend. I know it was nice to just not really think about school too much and, have time with my family. So I hope y'all are doing okay. And I want to kind of go through this week and make sure you're clear on what the goals are and kind of what the goal is for the end of the week. Okay, so for the end of the week, by Friday, I want us to be able to feel comfortable graphing all 6 of these functions. Okay, sine, cosine, tangent, cosecant, secant, and cotangent. So today we're going to do some multiple choice practice. Tomorrow we're going to have a quote unquote quiz. Obviously it's not really a quiz, and you can use your notes and stuff. So, it looks a little different than what a typical quiz would look like. But it would be kind of what we would do if we were in class. And then the quiz is only going to be over the last 4 graphs that we've done. So these 4, right? Oh, let me turn my pen on. These 4 here. So tangent, cosecant, secant, and cotangent. Those 4 will be on the quiz tomorrow. So what we're going to do now is we're going to kind of try to make a graphic organizer, basically. If we were in class, I'd give you a nice pretty piece of paper. We'd split it up into 6 sections and we would do this. So if you would get out a clean piece of paper, kind of make it fill up the whole page, okay? You can do it vertically like I have it, or you can do it horizontally. It was just easiest for me to have my paper this way on my iPad. And we're going to write down all 6 of the functions, and then we're going to talk about the amplitude and period of all 6, and then we'll do some multiple choice practice. Okay, so hopefully today shouldn't be too bad, because you're just going to be picking. You're not going to have to actually do any graphing, which is nice, but you definitely need to make sure you understand the basics of what the parent functions look like, these 6, before you can then choose. Okay, so I just realized I did not put my iPad on Do Not Disturb. Oops. So hopefully nobody calls. Maybe I'll do that real quick, so we don't have to worry about it. Let's put on airplane mode. Okay. Sorry about that. Alrighty. Doing a lot of FaceTiming these days. I bet some of y'all are as well. Alright, so let's talk about sine. Let's talk about the amplitude and the period first. And then we'll go in the order in which we learned them, which is just going to be going straight down. Or actually, I guess we then went side to side. Okay, we'll see in just a second. All right, so the amplitude for trig, for the sine trig function is 1, and the period is 2 pi over b. All right, which is typically just 2 pi. Alrighty, so we're going to go 4 to the right and 4 to the left, and just up 1 and down 1. And so it's 2 pi, pi over 2, and 3 pi over 2. Alright, and then I'm going to use a different color. Let's use black. And then sine starts at the origin, if you remember, and it goes up on the right, midline, down, midline. And then it does the opposite on the other side, so down on the right, midline, up, midline. And then it is a nice continuous graph. And y'all got into a really good habit of doing the range. We know what the domain is. The domain is negative infinity to infinity. And the range here is negative 1 to 1. And so the reason that it's negative infinity to infinity is because it keeps going to the left and to the right. And then the range, the lowest it goes is negative 1 here, and the highest it goes is there. Okay, now you do not have to do domain and range, so I'm going to erase it, but I just wanted to kind of review that in case, that was kind of on your mind. All right, now let's go down to cosine. So its amplitude is also 1, and its period is 2 pi over b. All right, so it's going to look very similar with the markings on the x and y axis. All right, and so now cosine starts at the amplitude up, and then it goes down on both sides, like so. I don't know if that might help, kind of doing the same thing on both sides. And then what letter should we see? We should see a W, okay, unless there's a reflection. All right, then we're going to go do the reciprocals of them. So we'll go to cosecant, and then we'll go to secant, these two. All right, so the amplitude, if you remember, is none for all of these other graphs. Now, I'm going to tell y'all that's a really big, important thing because, you know, if I ask you just simply tell me what the amplitude is, a lot of people are going to say 1 because of this right here. And I get that. Like, I totally understand why you might want to put 1, but we'll look at the graph to remind you of why it is not actually 1. Okay, now the period is still the same, 2 pi over b. Okay. And then our quote-unquote amp, if you remember me doing that, is 1. But that just means, like, if it's a vertical stretch or shrink or compression, and that means it hasn't changed. All right, so if we relate it to this trig function over here, anywhere that there's a point for a 0, remember, we now have a what? We have an asymptote. So now we're going to have an asymptote here. And then if you remember, it's every other one. Okay. And then we're just going to follow wherever there was a point here, like at 1, we're now going to have a point here at 1. And then wherever it was -1, we'll have the same. And then we draw our parabolas, which is just a fancy word for the U. This one's up or down a little too low. Let's erase that. Okay. And then you can kind of remember the same thing holds true with cosecant, that it goes up on the right and down on the left like sine does. Okay. And now the secant for, the amplitude for secant is still none, and the period is still 2 pi over b. So we're going to go same exact thing we've been doing. We just got to figure out where our asymptotes go. Okay, so we're going to go, we're going to start at the top just like cosine does, and then the asymptotes will be on every other tick mark. Okay, so down on the right. Oopsie, I messed that up. Do y'all see? I would have figured it out sooner or later, but I apologize I didn't get it quicker. Okay, so immediately to the right and to the left. And then every other one. And if you notice, if you try to line up these with the previous graph, you know, they're in like opposite spots. Okay, so they should not line up with each other. Secant and cosecant have their asymptotes in the different locations. Okay, all right, so our first point goes up at the amplitude, and then it's going to go down on both sides, and then it's going to go back up. Okay, so we have 3 going up and 2 going down. Alrighty, and then we're going to do tangent and cotangent. So our amplitude for tangent and cotangent is still none. Oh, and let me go back and explain to remind you of why it's none. Remember that amplitude means height, okay? There is no way, if this graph keeps going up and this graph goes down forever and ever and ever, there's no way to put a height on it. Okay, you cannot measure a height when it keeps going. And that's the same for all these graphs. The only ones that have a real true amplitude will be sine and cosine. Okay? And I'll just tell you that's a, oops, I almost messed up. That's a really important thing. Okay, so then the other important thing is this right here, so I might highlight that while I write, is that we've been doing 2 pi over b this whole time, and now we're doing pi over b. Okay? So remember, divide by 4, divide that period by 2, and then times the first tick mark by 3. All right. And so then we have asymptotes 2 to the right and 2 to the left. And then our tangent is an increasing graph. So it starts down, middle, up. And I saw on some of y'all's work, some of you were just leaving it like this. But remember, there's 2 more. So you got this one, like 2 more curves. Okay, so there should be 3 total. And then this one, like that. Okay. Alrighty, then cotangent's amplitude is none. Oops. And our period is pi over b. So we're going to do same thing. Alright, and then we're going to have our asymptotes are right in the middle and then right on the ends. And then cotangent is a decreasing graph. So it starts up and then it goes down. Like this, starts up, middle, down. Like so. Alright, so I'm going to highlight some of the things that I think are really important. Alright, these two have an amplitude of none. One, while the others have an amplitude of none. Okay, so that is going to be really important when you're just filling in plain old practice problems. Okay, can I get any other colors? Let's see, yeah, okay. This period for all of them are 2 pi over b, and then these are pi over b. Okay, so those are kind of the big things that I want to make sure that they stand out to you. Okay, so now I'm going to do 4. I've planned out 4 of them. Where'd they go? Okay, I have them written down over here to the side. Multiple choice practice problems for you, and then so you can kind of hear some reasoning and how I figure these things out. And then you're going to try the other, how many are there? 16, I think. So there's 12 more that you're going to try. All right, and it'll be really easy for me to grade and give you feedback because all you're going to type is like number 2 is A, number 3 is B, number 4 is C, etc. And then I can say, yes, 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 try number 12 again or something like that. Okay? All right, so if y'all remember, we've done some of these before together. So if y'all remember, I'm trying to look for the key things that I think are the most important, being this and that. So if you remember what those two numbers do, it should help us a lot. So that 1 is our vertical shift. So that means it's going to go up 1. And then this 1/2 is our vertical compression, which means it's going to be shorter. Okay? And so basically, I'm going to go look for this first because this is where the midline should be, if y'all remember. Okay, so let's go see if we can mark in the midline on these graphs. So on A, do y'all see it's at the x-axis, so that one's out. All right, B, it looks like it could be at -1. Oh, we don't want it at -1. I was trying to say it was -1. This graph has been moved down, so it's out. How do I know that C is out immediately? Well, because we're looking at the cosine function. And I should have said that really from the beginning, but a cosine function is our wave, right? And the one that looks like an M. So obviously letter C is like either secant or cosecant, so it's out. And so we think it's D. Now let's be sure. Okay, is this oh, sorry, I'm not perfectly right on the center. But can y'all see the midline should be right in the middle? And is it at 1? It is, because these go by 2s. So it is at 1. Like what we wanted here from this number, and is the amplitude then up 1/2 and down 1/2. So basically only from here to here and here to here, that's 1/2. And it's so small I can barely write in there, but that is true. So if y'all remember, amplitude is from the midline up and the midline down. Should be the same. Okay, all right, I want you to try 2 similarly, and you can go back to this in a minute. I'm just going to go skip down and I'm going to do number 3. Okay. All right, so we do not have a vertical shift at all. We only have an amplitude, and that would be a quote-unquote amp of 2, which means it's a vertical stretch. Well, it's very hard to tell on these, like what is a vertical stretch. Now, I don't know if you can tell, but like these look more stretched out to me. Well, that one's okay, but can y'all see that this one looks like a vertical compression? It looks wider to me. Like this graph is taking much longer in this area here to kind of, it's more flattened out, if you will. These other ones look steeper. See how this like almost looks like a straight line? So that means they're steeper, so they've been stretched. Okay, now, other than that, it's real hard to tell. Okay, and I will say that this number right, oopsie, wrong thing I wanted to do. This number right here will help us find the period. So here's the thing. Some of these are going to be tricky, and so I want you to take out a piece of paper as you work through these and do a little scratch work. Now, I'm not asking you to do the whole graph, okay? I really, truly, honestly believe if you can do the asymptotes, it'll be, like, just think through where the asymptotes go. It'll make life a lot easier. All right, well, the first thing is our period has changed, right? There's an imaginary 1 right here, if you remember. So we're going to do pi over b. Is everybody good? It's 1/2 because that whole number right there. So what is our new period? Our new period is 2 pi by keep, change, flip. Does everybody kind of see that? So I went to the amplitude first. The amplitude doesn't honestly really help me that much. So now I'm going to kind of graph it the way that I'm used to graphing it, and then see if I can kind of compare it to the answer choices. Now notice all of my graphs here do not have negatives, so I'm not even worried about this side. Okay, I'm just going to worry about the positive. All right, so tangent has asymptotes 2 to the right and 2 to the left. Well, I'm not going to worry about the left. Okay, so if it's an increasing graph, you remember it goes here, here, here. So it should go like that. Well, all you're noticing on this graph is this point here, right? So we want it to start at the origin. Well, all of these do, so that does not really help us, okay? But what I do think will help us is this right here, the asymptote. Oh, I keep grabbing the eraser instead of the highlighter. My bad. Okay, so I want to try to find where my asymptote is going to be pi. Okay? So if I come over here to my graph and I draw in the asymptotes. Now, how did I know where the asymptote went just then? Well, I basically just figured out where the gap was between this parabola. That's not a parabola. That cubic and this cubic. All right? So it's basically just the space in between them. And that, you guys, falls right at pi. And isn't that what we wanted? Yep. So ding, 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 that's our winner. Okay, that's our answer. Now, let's make sure we understand why the others are not our answer. So can y'all see the asymptote's going to fall in here because it's the space between those two, and then it would also fall here. Well, that one falls at pi over 2, and that's not what we want. Our first asymptote is going to fall like here. It's really, really tight in between these, okay? So it's going to fall somewhere like pi over 4. It's not even labeled, so that's not it. And then this one falls here, which is between pi and 2 pi, which would be like 1.5 pi, and so that's not it either. Okay, so does everybody kind of see what I did was I graphed my own version and then found which asymptote matched up with mine. Okay? All right, let's do another one. Okay, so we're going to do another similar one. I think this one's a slight bit easier because the 3 is a little easier to see with secant and cosecant because of the parabolas like spreading out or getting closer. So does the 3 mean a vertical stretch or does it mean a vertical compression? Well, the 3 means a vertical stretch. So that means the parabolas should be further apart from each other, 3 times as far. Okay, so can y'all tell these are like real close together here on A? So that's probably not it. Okay. All right, so my midline appears to be here, and how far up is this parabola and down is this parabola? It appears that they're only 1 away from the midline, so that means the amplitude would be 1. So that one's out. All right, the midline looks to be here, and the reason I know that is because it's like equidistant. You know, it's in the middle, essentially. All right, so how far up does this parabola go and down? This goes up 2, and then another one, so that's 3. 2, this is 3, and then this distance from here to here is also 3. So that looks like it could be our answer. Let's see if the other ones work or don't work. So this is the height of these. The distance away is only 2, so that means our amplitude has to be 3, which is C. Okay, so you see how the amplitude really helped us. It's just the distance away from the midline. Okay. All right. And now let's try number 9. Okay, now we haven't done this yet, but I think you guys, based on your prior knowledge, will be able to understand it. Okay, so this -1 is a vertical shift, okay? So that means it's going to go down 1. So that's where our midline is going to be located, okay? So our midline should be located at -1, which means the lowest, or the line that's in between the parabolas, okay? So let's try to figure out. So this point is at 1, and this one is at -3. So I think that one's going to be at -1. Now let's just double check. So this one is 1, 2 away, and this one is 1, 2 away. So can y'all tell the amplitude on this graph is going to be 2? And is that what we want? What is our amplitude, or excuse me, my quote-unquote amplitude? It's a 1, so A's out. Okay? All right, so here's that 0, here's that -2, so the midline would be at -1. And again, that's what we want. And so now, is the amplitude 1? Are they 1 away from the midline? And the answer is yes. So we think B could be the answer. All right. This one appears to be the same. All right, so C could also, it could be B and it could be C so far, because of the whole, it goes down 1 and it has an amplitude of 1. And then D is out because the midline is at +1, up 1, and so that's not it. Okay, so how do we distinguish between B and C? Because they kind of look similar. Well, it's all based on the period. So this B is going to help us with our period. All right, so what is the period for cosecant? Is it 2 pi over b, or is it pi over b? Hopefully you remember that it's 2 pi over b. Okay, so we're going to have 2 pi over 2, which means our period should be pi. And you guys, I'm just going to sketch the right side of the graph. Okay, and if you remember this 2, because it's greater than 1, that's a horizontal compression, meaning it's occurring more frequently. And then all I'm going to do is try to get my asymptote set and then try to compare, is it B or C? All right, so how does cosecant look? Well, cosecant is the reciprocal of sine. Okay, and sine starts at the origin. Well, can I have a point at the origin? The answer is no. So we need an asymptote here, which these both look like they have an asymptote there, so that doesn't really help us. And then the next asymptote should be at pi over 2 and then at pi. Okay, so let's see if we can draw these in and see which ones are at pi over 2 and then at pi. That one looked like it was at pi over 2 and at pi. Now let's disprove this one. So pi and 2 pi. Yep. So if we want our first asymptote to be at pi over 2 and our second asymptote to be at pi, then B is our best choice. Now, these are going to take a little bit of practice, okay, you guys? I don't want you to just think you're probably going to get it all right on the first try. It may take me saying, no, try again. So please, 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 do your best to give me some feedback, or give me your answer so I can give you feedback, okay? I'm going to bring the questions up if you want to, like, pause the video. As I show these, I'm going to, like, pause for a few seconds for each page. So I would like for you to try 2 here, pause and give it a try. I want you to try 4 here. Now this one is a little tricky because you need to draw in your asymptotes. So make sure you kind of think that through. And actually, it's not terrible because of the whole, there's no vertical shift. So that should help a little bit as well. All right, number 6 can be a little tricky because it's hard to tell the quote-unquote amplitude here of 3. So I think the period is going to help you out the most on number 6 and sketching it yourself. 7 can be a little tricky as well, so I would suggest sketching it yourself. It's all based on the period, and so is number 8. Now, number 8, you should be able to knock out 2 of them pretty immediately that don't even look like sine. Okay? And then I would like for you to try 10 here. Hopefully that plus 2 will help you a little bit. And then here are 11 and 12. 11 again is a little tricky because of it's hard to see that amplitude of 1/2. So I would do the period if I were you to try to find that one. 12, we did one like it, so I don't think 12 should be as bad if you try to find the midline. And then 13 and 14, I don't think should be too bad if you use the amplitude and the vertical shift. Hopefully that will help on those two. And then lastly, try these. Okay, again, I think these are easier because of it's almost like if there's more things to look at, then it's easier to find it. So if you look at the vertical shift and then the amplitude, I think you should be able to get these. All right, I hope y'all will try these and give me some responses. I've kind of had I don't know, I feel like some of you have kind of dwindled off and not really done as much, but I hope maybe at the beginning of this week you'll kind of start fresh and try your best with these. Awesome. All right, miss you guys.